what is the expected product from the following synthesis? We see a cyclic ester, we're going to react it with a methyl magnesium bromine, an acid, and then a PCC. Well, looking at that, anytime I have an alkyl magnesium bromide and an acid workup in the next step, that's going to be a Grignard reaction. PCC and DCM, that's an oxidizing agent. So we're going to have a Grignard reaction and then an oxidation. And so anytime I see a Grignard, I know it's a good nucleophile. And anytime I see a carbonyl, I know it's a good electrophile. So anytime I see a Grignard and a carbonyl, I should be thinking, oh, they're going to react with each other. And they are. Our Grignard reagent is going to come in, it's going to attack that carbonyl, open it up, and then that carbonyl is going to reform and eject out the other oxygen group on the ester. We're showing a sort of abbreviated mechanism here, but it's opening, it's closing, it's ejecting out the other oxygen. Then because we've reformed the carbonyl, we still have a carbonyl to attack, and because they told us it's excess in our reaction, we know that we have more Grignard reagent that can attack that carbonyl. And so it's gonna happen again, right? This reaction is so nice, it happens twice. Now we'll have those two alkoxide groups, which when we do our acid workup, we'll protonate both of them, and we'll get a diol, a molecule with two alcohol groups. So we have our PCC and DCM, that's our last step, and that's going to oxidize our alcohol groups. But when we're working with alcohols, we have to remember there has to be a hydrogen available on that carbon attached to the alcohol group. That is, we can only do this with primary and secondary alcohols. So if we look at that top alcohol group on the molecule, we see that it's tertiary because it has 3 carbons and no hydrogens attached to its alpha carbon. The alcohol group on the bottom is secondary because it has 2 carbons and 1 hydrogen attached to its alpha carbon. So when we use our PCC, it's not going to be able to oxidize our tertiary alcohol on the top, but it will be able to oxidize our secondary alcohol on the bottom, which will turn it into a ketone and we'll get our final product. Now all we have to do is compare it to our options, and the final answer is C. Nice! If this was helpful to you, be sure to follow for more tips and tricks.